All right, here's your review video part 2. Just a reminder here that sometimes you'll need to tell which quadrant or on which axis these points might fall. And so here for -3, -4, we'd start at 0, 0, go to -3, and then down to -4, and we see that that would lie in quadrant 3. If your ordered pair has a 0 in it, then it's going to lie either on the x-axis or the y-axis. So let's look at E here. Tells us don't go right or left at all, it's at 0, but go down to -2. So that point would be right here, which is on the y-axis. So for that problem, you would select y-axis. Look at G, that says go over to 6, but don't go up or down at all because the second coordinate is 0, and so that point would lie on the x-axis. When we are graphing these equations, remember that we take the values that we are given for x and we replace them in the equation and figure out what the y value would be. So for instance, this first one is -4. So we take the -4 and replace it in for the x. -4 plus 5 would be then a +1. And so our ordered pair is -4, 1. And then we would graph that on our graph grid. So -4, +1. And we would go ahead and finish all of these and then draw that line in, and it will make a straight line. So let's try one more here. So -1 plus 5 would give me 4. And so it would be -1, 4. So we can see our line is going to go this way. If any of those points don't fall in that line, then that means that we either computed it incorrectly or we graphed it incorrectly. All right, this should make a straight line. So you can see here when you're graphing those equations, you're going to get something that looks like this. It won't always go that same way, but the idea is it will make a straight line. Now here's a situation where we are graphing a polygon. So we'll graph all 4 of these points and it'll make a rectangle. And then we'll count the spaces to get the length and count the spaces to get the width. And it doesn't really matter which you call length or width. They're interchangeable. And then we'll add all 4 sides together to get the perimeter and multiply length times width to get the area. Now in these problems you have to do a little bit of problem solving. It says if the perimeter of the rectangle is 12 units, and remember perimeter is add up all the sides, what are the possible coordinates to complete the rectangle? And there'll be 2 sets. This will be an ordered pair, another ordered pair. So in other words, you're having 4 ordered pairs here because there are 2 options. You can go up or you can go down. So our first point here is -6, 4. So over to -6 and up 1, 2, 3, 4. Put a point right there. And then -2, 4. So over to -2 and up 1, 2, 3, 4. All right, so here's our line right here. And you can see that that is 4 units long. All right, so we've got 4 units for that edge, and then we know we'll have another edge that has 4 units. So that's 8 units altogether out of the 12 that I have available for the perimeter. So if we take 12 and subtract the 8 units for the perimeter that we've already used, we have 4 left. That means the sides have to be only 2 units long because we've got to divide that 4 units up between the 2 sides. So my options are to go down 2, and so right here will be 2 that will be my one coordinate, and that will be my other coordinate. Or my options are to go up 2. That's another option, right? So see, those lines are just lovely. But so those are my 2 options right there, okay? All right, so you can see here I'm looking at -6, 2 for one of my ordered pairs, and -2, 2 for the second. That would make that rectangle that has a perimeter then of 12 units. Or I could go up 2, and so I could be at -6, 6, and -2, 6. And that would be the other 2 sets of ordered pairs that would make a rectangle with a perimeter of 12. Now this problem is similar, except now we're dealing with area, which means the space inside. So we'll graph the 2 points we have, which are 1, -2, over 1, down 2. And then also over 8, down 2 for my 8, -2. This says that we want an area of 21. So if we draw this line in, we can see that's 7 spaces here. And so in order to get an area of 21, remember that area is length times width. And so we need 3 units on the other side. So in order to get the 3 units that I need on the end sides here, I'm going to go up from my original graph line 3 units. And so 1, 1 and 8, 1 would be one option, or 1, -5 and 8, -5 would be another option to complete a rectangle that has a length of 7 and a width of 3 for an area of 21. Then the last section that we covered is this independent and dependent variable idea. Remember, the independent variable will cause the dependent variable to happen. So this says Lindsay went to the eye doctor to see if she needed glasses. When she stood closer, she could read the eye chart better. Standing further back, she had trouble reading the eye chart. So the distance she is away from the chart is our independent variable, and how well she can read is our dependent variable. So distance from chart is my independent, and ability to read the chart is my dependent variable. The distance from the chart causes me to be able to read the chart either better or worse. All right? Okay, so that's independent, dependent there. All right, guys, good luck on your test. I know you can do a good job on this, and I'm wishing you all the best.